Hi, I'm Jorden Gentry and I'm doing synaptic communication. This is a neuron, and the neuron has a cell body, which is the head of the cell, and the head of the cell has dendrites. Then there goes to the skinny part, which is the axon, which leads to the axon terminals. The axon terminals communicate with the dendrites of the next cell, forming a synapse. Here we have a larger view of the axon. It has myelin sheaths which help in allowing the signal to travel faster. You can see at the resting potential, sodium is extracellular and potassium is intracellular. This means that there is a positive charge on the outside of the cell and a negative charge on the inside of the cell. Once the axon passes the threshold, then the cell undergoes propagation. Propagation is when an electrical signal increases and is sent across the cell. When the signal arrives, the sodium is transported into the cell, making the cell positive and the outside of the cell negative. Once the signal passes, potassium is moved outside of the cell according to its concentration gradient, and this is called the refractory period. The cell is negative, and the outside of the cell is positive. Then the sodium-potassium pump begins and transfers the sodium out of and the potassium in. Then the cell is returned to its resting potential and is ready to receive another signal. The action potential does not last very long and is just a few nanoseconds. A is the resting potential, and this is around -70 millivolts. B shows the polarization in which the sodium ion channels open and sodium is moved into the cell. C is repolarization, in which the sodium ion channels are closed and potassium ion channels are opened. D is the refractory period, in which the sodium-potassium pump is used to move sodium out and take the potassium back in. This occurs in order to allow the cell to return to its resting potential, and E is the threshold in which needs to be passed in order to have an action potential. We then look at a synapse. The axon terminal is the presynaptic neuron, and the dendrite of the next cell is the postsynaptic neuron. There are two classes of neurotransmitters, which are excitatory and inhibitory. Excitatory are both sodium and calcium traveling into the cell, causing depolarization, which promotes action potentials. Inhibitory neurotransmitters are when chloride goes into the cell and potassium flows out of the cell, which suppresses action potentials. In order for exocytosis to occur, calcium ions need to be in the axon terminal. Then is packaged up and through the process of exocytosis is released into the synaptic cleft. The time it takes for the neurotransmitter to get from the axon terminal to the dendrite of the next cell is called the synaptic delay. When the neurotransmitters reach the dendrite, they are passed into the cell through the ionotropic receptors. Then the neurotransmitters are in the postsynaptic neuron. And that is how synaptic communication works.